Hello students, welcome to the class. I hope you all are safe and sound at home. In the previous class, we have completed till exercise 6E. In today's class, we will know about types of angles, then perpendicular lines, parallel lines, then drawing parallel lines with set squares. So let's begin the class. Types of angles. Angles can be classified into following categories according to their measures. So angles are categorized according to their measure. The first one is acute angle. An angle whose measure is more than 0 degree but less than 90 degree is called an acute angle. In this figure, you can see here angle ABC is less than 90 degree, so it is an acute angle. Then right angle, an angle whose measure is 90 degree and is called a right angle. In figure A, this you can see here it is a right angle, angle ABC. So it is as it is a 90 degree, so it is a right angle. Angle which measure 90 degree is always a right angle. Obtuse angle, an angle whose measure is greater than 90 degree but less than 180 degree is called an obtuse angle. So an angle is more than 90 degree but less than 180 degree is known as obtuse angle, and here you can see in this figure angle ABC is greater than 90 degree but less than 180 degree. You can also measure it with the help of a protractor, as place a protractor on the baseline BC here with a point B. You can check, read from the right side here, and this is 120 degree. So this is more than 90 degree but less than 180 degree. So it is an obtuse angle. Now straight angle. An angle whose measure is 180 degree is called a straight angle. In figure, angle ABC is a straight angle. Now let's do exercise 6F. Number A, classify the following angles as acute, obtuse or right angle. So here this is 90 degrees, so it is a right angle. You can write it in your copy. Here I am showing you how to write right angle. Here number 2 is 130 degree. So here is 130 degree, so it is an obtuse angle, as 130 is more than 90 degree but less than 180 degree. So it is obtuse angle. Now here number 3, see this is 25, more than 0 degree but less than 90 degree. So it is an acute angle. Now number 6, this is 175 degree. It is more than 90 degree but less than 180 degree. So this is obtuse angle. Now number 7 is 91 degree. It's not 90 degree. Don't get confused. It's not 90 degree. It is obtuse angle. More than 90 degree but less than 180 degree. So it is obtuse angle. Now number B, classify the following angles as acute, right, obtuse or straight. So it's in the same way you have to write. It is 42 degrees, so it is acute angle. Now 92, so it is obtuse, more than 90 degree but less than 180 degree. Now here this is 180 degree, so it is a straight angle, as I am writing in the book, but I will suggest you to write in your notebook. So here number 7 is right angle 90 degree. Now let's do exercise 6G. In exercise 6G, you need a ruler, a protractor, set square, a pencil and a pen. First, let me tell you about perpendicular lines. We say that the electric pole is perpendicular to the ground, the wall is perpendicular to the floor of the room. When we stand erect, we are perpendicular to the floor. Is horizontal and the line segment OP is vertical. We can say that the line segment MN and OP are perpendicular to each other. Here we see that when two lines are perpendicular to each other, the angles formed are right angle. So to know whether the two lines segment are perpendicular, we can use the protractor and measure the angle. Here we use the protractor and measure the angle. See, this is 90 degree. First we place on the baseline MN with the point O. See, this is a 90 degree. And any of the angles is a right angle, then all other angles will be right angle, will be 90 degree. We can also extend the line here and we get all the angle as 90 degree. So here you can see angle POM or MOP. MOP is 90 degree. NOP is also 90 degree. Then MOQ is 90 degree and NOQ is also 90 degree. And here I have shown you to measure have shown you about the use of a protractor for the perpendicular lines to draw perpendicular lines, but you can also use the set square that you will come to know in this exercise. So first let's start doing the sums from the exercise 6G. Here 6G, state whether the line segments are perpendicular to each other or not. Write yes or no. See number A, this is perpendicular. See, this is making a right angle. When two lines are perpendicular to each other, they make a right angle. So this is a right angle. So this is perpendicular. See here, I have placed the protractor over this line, the base line. You can check by using C, 90 degree. So this is the line segment are perpendicular to each other. You can also check. See, this is a tilted. The base line is tilted, slight tilted, but this is perpendicular. Okay, and C is also perpendicular. It doesn't matter that the base line is at the top or at the bottom, but the line should be perpendicular to each other. So this is perpendicular. Three of the line segments are perpendicular to each other. Now here number D, this is intersecting line. As both the lines are intersecting each other, they are not perpendicular to each other. This is intersecting line. So it is not perpendicular to each other. Number E also. And number F is perpendicular to each other. The line segments are perpendicular to each other. Here, let's do number 2. Draw line segment AB 5 cm Mark a point C on it. Draw a line segment CD perpendicular to AB using protractor. So here first we have to draw a line segment of 5 centimeter by taking 5 centimeter measurement. Now we have to mark a point on it and draw a line segment CD showing the line segment CD perpendicular to AB using the protractor. So here exercise 6G number 2. So first we take a ruler and draw a line segment of 5 centimeters starting from the 0 mark till 5. Centimeter. Then mark here as AB. The line segment is of 5 centimeter. Then mark a point C on it. This is of 5 centimeter. We can take a midpoint or we can mark anywhere on this line. We can take a midpoint or anywhere. I am taking here C. Now take a protractor and place on a baseline AB with a point C here, and we take 90 degree, mark 90 degree and mark it as a point D. Then lift the protractor and join D, CD with the help of a ruler. And here CD is perpendicular to AB. Here CD is perpendicular to AB. And here we have constructed a line segment CD perpendicular to AB by using protractor. Now here the third question. Draw a line segment CD equals to 6.3 centimeter. Mark a point E on it. Draw a line segment EF perpendicular to CD using set square. Here by using set square we have to show the perpendicular. We have to draw a line segment EF perpendicular to CD. So first let us understand about set square. What is set square? The use of a set square. Let us know about set square first. You have seen the two types of set square in the geometry box. When you purchase the geometry box from the market, you get this set square in it. Here, in this set square, see, it is 90 degree, 60 degree, and this 30 degree. So here we can also draw with the help of a set square the different measure. You can draw 90 degree, then 60 degree, 30 degree, 45 degree, 75 degree, and it is also used to draw perpendicular and as well as parallel lines. So, and here this is the shortest side of the set square, this is the longest side, and we all know the sum of all the angles of a triangle is equals to 180 degree. So this is 90 degree, this is 60 degree, and this is 30 degree. 60 plus 30, 90, and 90 equals to 180 degree. And again in this is 90 degree, 45 degree, and 45 degree. So sum of all the angles equals to 180 degree. So now let's solve the sum. Now here number 3. First draw a line segment taking measurement 6.3 from point O. 6.3 here 6, then 1, 2 and 3. 6.3 and mark as CD. Then mark a point E on it. And mark point E on it anywhere you can mark. I'm marking here E. Now here first we place the edge of the set square coinciding with CD, with the line CD, and hold it so that it won't get disturbed. We have to hold it tightly. Then we place the another set square, the corner having the right angle of the set square, and coincide with point E. Then we see this is making right angle, and then we join the line in this position. Then we draw a line this position. We lift the set square, we get here perpendicular line, and mark the point as here, mark it as F. So here we get EF perpendicular to CD. Now number 5, draw a line segment AB, mark a point C above it, and draw a line segment through C parallel to AB. Here in this question, you have to draw a line segment, then we have to mark a point C above it, and we have to draw a line segment through C parallel to AB. Number 5. Here we are going to draw a line parallel to line AB through a point C. First we draw a line with the help of a ruler by taking any measurement, and then we mark a point as AB, a line segment AB. Then mark a point C above line segment AB. Here marking a point C. Now we place the longest side of the set square against the line AB, and then place the ruler at the shortest side of the set square. Make sure the ruler lies nicely on the shortest side. Then slide the set square along the ruler until we reach point C. And here we use the edge of the set square to draw a line through point C. Now we lift the ruler and a set square. Here we get a line parallel to AB. Here we can also extend the line to the left side. That's all for today. We'll continue the same chapter in the next class.